So today I will talk about our technology, which is named carbon-FX technology. And we basically convert biomass into biocarbon. So first, who we are. We are a technology developer and a producer of high-quality biocarbon. We are a spin-off of Airex industry, which is a manufacturer of dust collectors based here in Quebec. And we are now starting commercialization of our carbon-FX technology, a simple, reliable, and cost-competitive technology platform. So what is torrefaction? Torrefaction is really a simple process. You just heat biomass in the absence of oxygen. So the goal is to drive off the volatiles and to increase the carbon content of the biomass. And in doing so, you are also increasing the energy content. So basically, biocarbon looks like charcoal that you may have used in your barbecue. So it's black, brittle, and it's dry, and it has a high energy density. We are using sawdust or any wood residues in our process, but we could use any organic residue. So I was quite pleased to see the bagasse mountain that we see this morning. That will be a great feedstock for our process. The biocarbon market. So I've put in this table the different products that we can produce depending on the carbonization level. So the carbonization level depends on the temperature inside your reactor and the residence time into the reactor. So you have the product that it replaces. Yeah, the name of the product and the usage. When I started in this business 5 years ago, there was only one box in this table. So basically, torrefaction technology has been developed to replace coal in coal power plant. It all started in Europe, because in Europe, they have a lot of coal power plant, and they had to reduce their GHG emission. So they started burning biomass instead of coal in their coal power plant. But they realized it was quite difficult to use raw biomass into pulverized coal power plant, which is 95% of the coal power plant on the planet. Because in this kind of power plant, you just grind the coal and you push it into the, you blow it into the boiler, and it produces a giant ball of fire. So it was very difficult to do this with raw biomass. So the utilities started asking technology companies, hey guys, can you come up with a process to transform biomass into something that is a drop-in replacement for coal? So all these technology developments started in 2005 in Europe, and now we are at the second generation of these technology. So if we look a little bit about these markets, so basically we replace coal. To do that, we take the biocoal, but we densify it to lower the transportation costs. So it's really like a pellet that you will find in any, that is used in household appliance, but it's a pellets of biocoal. So it replaces coal in power plant, but in cement plant and or lime plant as well. The first market here, it's wood flour. So wood flour is already used in composite. So the decking that you have in your, on your patio, it's made maybe with 50% wood fiber. If you torrefy that wood fiber, it gives new property of the material, so it can replace wood flour in certain application. For the soil market, we call the product biochar, so it's a soil enhancer. So it helps water retention, it helps the microbes life, it gives back carbon to the soil. So it's a very interesting product, and there's more than 5,000 scientific publications every year on that topic. So it's going to be a huge product in the next few years. The chemical, this is the last one, the latest one that we're working on with a chemical company. So they want to replace carbon black in their process. Carbon black is used in the tire industry. It's the bulk of the market, but it's also used in other markets as a pigment. So to to give color to a product. So they're using now carbon black. Carbon black is made by fossil fuel. It's quite expensive, so with biochar, it's both renewable and less expensive. Metallurgy, if you want to reduce iron or silicon, you're using either coal or coke. So we're working with a silicon company that want to replace their coal and coke with biochar. And the purification market, it's basically the activated carbon. So we can use biochar instead of activated carbon. It's less expensive and it helps purify the liquid stream. So we're working with a mining industry where they have to lower their emissions of, let's say, copper in their effluent. They cannot use activated carbon because it's too expensive, but biochar gives almost the same result at a price that is substantially lower. Some number of the markets. So thermal market is a huge market. So we want to produce a drop-in replacement for coal. You have here one of the first coal power plant in the world that has been converted to run on biocoal. So in Ontario, they have banned coal usage several years ago, and they have converted 2 of their power plants to use biomass. The first one in Atikokan, they converted to wood pellets, because wood pellet is the standard solid biofuel on the market right now. They had to invest $170 million to convert that plant to burn wood pellets. For their second conversion in Thunder Bay, they decided to go directly to biocoal. And the conversion cost for that was only $5 million because biocoal is really a drop-in replacement. So they didn't have to install new grinders, silos, burners in their plant. So there's really a huge advantage. Just yesterday, I was giving a presentation to a Chinese delegation. In China, they have over 2,500 coal power plants. They are burning 3.6 billion tons of coal per year. And they are building 2 new coal power plants, not per year, not per month, but every week. So this is really scary in a sense. So we have to find a new fuel to power these power plants. Otherwise, it's going to be a catastrophe for the climate. The soil market, this is an emerging market. So there's very few producers now that is producing biochar. So we're working with different companies in the retail, garden, and landscaping. They're mixing biochar with compost to produce a new product to their customers. We're working on soil remediation and on forest revegetation. Technology roadmap. So it's very long to develop these technology. We started in 2010, and we have invested over $14 million so far to build our first commercial plant. So we started with a proof of concept in 2010. A very small unit. We then built 2 pilot scale units, 250 kilogram per hour unit. These units are now used in research center at Innofib and Cette in Quebec. And we have started the operation of our 2 tons per hour unit last year. So the plant is located in Bécancour. It's about 2-hour drive from Montreal. If you want to see a complete video of the plant, we have one on our website. We just completed a video with Ecotech, which is the clean tech cluster in Quebec. So the plant has a 2 tons per hour capacity. The investment was $6.5 million just for the plant. Feedstock, we're using 2 types of feedstock, sawdust and recycled wood. So recycled wood is a product that is widely available in Quebec. There will be a ban on that landfilling. So it's a product that is already dry. It behaves very well in our reactor once it's mixed with sawdust. The end product, we're producing biocoal pellets. We can produce also white pellets because the technology could be used just to dry biomass. We're producing biochar and torrefied wood flour. So this is the process. We receive the biomass in moving truck floors. We have 2 silos for the 2 different kind of feedstock. We have a hammer mill to reduce the particle size. So we're working with very small particle size. We have a flash drying system where we remove about 20% moisture content of the biomass. And we use the residual heat from the process to do that. We then go into the carbonifics to transform biomass into biocoal. And we either go directly in a silo if we produce biochar, or we go in a pellet mill if we want to produce biocoal pellets. So the capacity depends on the end product, because the more you carbonize, the more you driving off volatiles. So the mass yield will be quite different if you are only drying the biomass or you fully carbonize it. So that's why you have these different capacity. It's a cost competitive plant. We've designed the plant to be about the same cost of a white wood pellet plant, because the only difference in these 2 plants is that you replace the wood dryer, the drum dryer, with a reactor. No market risk for our customers, because biocoal is still an emerging market. They can produce white pellet during that time. So some example of the product. So you have the biocoal pellets, the white pellets, the biochar, which is in powder, and the torrefied wood flour for a composite, which is used either with polyethylene or polypropylene. This is the reactor itself, the carbonific system. So we're feeding from the top here. We have a pre-heating zone. We call it the conditioning chamber, where we heat the biomass indirectly. On the bottom, you have the combustion chamber, where we burn the torrefaction gas to produce the heat for the process. These are the reactor. So we are using a unique reactor. It's a cyclone-based reactor. So inside these boxes, you have 4 reactors. So we have 8 reactors total. It's a very simple reactor. And it's a very fast process. So we're doing the torrefaction in about 3 seconds. That compares to about 30 minutes for other technology that are under development. Why we are able to do that is because we're using small particle size, and because we have a highly turbulent flow inside the reactor. So we have a very good heat exchange. You have the extracting screw here and rotary valve to keep the oxygen outside of the system. We have these rotary valves at the beginning of the process also. And we go into another screw conveyor. This is the feeding system, the raw material that goes into the 2 silos. We can mix those 2 different feedstock, and we go into the hammer mill, which is here. And we then go into a 3rd silo at the left. You have here the standard pellet mill to produce the pellets, and we go outside, we cool the pellets, and we go in the silo. So you can see that it's a very clean plant. If you have visited pellet plant before or just a sawmill, everything is enclosed because dust is very dangerous. So the conveyor are enclosed, the silos. So we have dust collection to be sure that we don't have dust. We have installed sprinklers. We have explosion damper. So we have a lot of security system, because biomass powder is combustible, but torrefied biomass powder is even more combustible. The equipment inside, so we receive the biomass into this megadome, and the 2 silos for the final product, and the silo for the truck station. So cost competitive technology, we have the smallest footprint because we only have 3 seconds of residence time inside the reactor. The reactor are very small compared to all the other technology. We have an integrated pre-drying system, so we don't have to install a complete drum dryer or a belt dryer in front of our system. And it performs as a high-efficiency biomass dryer. It's a scalable technology, so we're using multi-cyclone, and that came from the parent company, which is specialized in dust collectors. So we have multiple cyclones. So if we want to have to increase capacity, we will just put more cyclones in parallel. And it has been an incremental technology development, so we've been very prudent with that technology development. We took one step at a time to build the plant that we have today. Some R&D that we are doing, so basically we are testing different kind of feedstock. Some of the feedstock that we have tested so far, so bark, sawdust, recycled wood, compost, and corn stover that we have tested, and the different product that we are producing. Some project that we are doing with partners, so like the first one was for the activated carbon. We've worked with Rio Tinto to produce a high carbon content product. We're working with a different project for the biochar and the torrefied wood flour. So if you have any new ideas, I would like to have an even bigger table in next year with new usage of that product. So if you're using carbon in your process, think about biocarbon that could replace your fossil fuel carbon. These are our funding partners. So as I said, we've raised about $14 million so far. We have 2 investors, Venture Cap, Cycle Capital, and Desjardins Innovatech. We've been backed by STDC, the Quebec government through the Technoclimat program, the Natural Resource Canada, and the parent company, Airex Industry. And R&D partners, we work with FP Innovation, which is a large R&D organization in the wood forest product, the City, Innofib, Resolute Forest Product, which is a pulp and paper producer. We've been funded by CRIBIQ, NSERC, and Lauson, which is our partner for the pellets. So that's all I have for you today. You have my contact information, and I invite you to visit our website if you want to see the video of the plant. Thank you.
Time for a few questions before the coffee break. Yes, please.
Technical, but you said your cyclones can't have oxygen.
No.
What gas are you using? How are you managing that?
We're using the flue gas from the combustion chamber. So we are measuring the oxygen with a probe that control the air for the combustion. So basically we're at 2-3% of oxygen content inside the loop.
And that flue gas can be used as a fuel source?
Yeah, it's the flue gas. We do first the indirect heating into the conditioning chamber, and then it goes directly in contact with the biomass particles. So it's a mix of flue gas, torrefaction gas, steam that is always running. Yeah, so we're pushing new air for the combustion, and we're exhausting some of that combustion flue gas by the chimney.
Thank you. Any question? Yes, please.
Do you have any fresh input of gas?
For the startup, so we have to heat the system in the morning when we start operation. Once the process has started, we just keep a pilot flame to keep the burning running. So we're using natural gas to do that. So it's a very low consumption. It's about the same size as a barbecue.
Questions? 1, 2, 3. So,
Thank you.